Good morning, everyone. My name is Felienne. I'm assistant professor at Delft University of Technology. And welcome to NDC, I guess. Let's start this morning actively with a small quiz. Who knows who said this? Any takers? Bill Gates. Any other guesses?
Any programmer.
Have you seen this talk before? Yes. Really, I have heard every programmer ever say, oh, programming is like the best thing. Everyone should learn programming because it's the future and it's exciting. And yes, we love this. However, of course, this sentiment brings on a very interesting question. Because if we say everyone should learn programming, what do we mean exactly by programming? Apparently, we have this feeling, but we don't really have a very clear definition. If you ask people what programming is, if you ask 100 developers, probably you will get 100 answers. It's not really very clear what programming is. And this is especially difficult for us being programmers. Maybe you know this joke about 3 fishes swimming in the water. I love this joke. And the big fish says, hey, fox, how's the water? To the 2 small fishes. And the 2 fishes say, what's water? They don't know what water is, because the only thing they have ever been in is water. They don't know that there's something that is not water, that you could pull them out of the water, and that suddenly they would be in something not watery, like air, and it would be dangerous. These fishes don't really have a very good conception of what water is, because the only thing they know is water. For them, the world is synonymous to water. And in a sense, this is a little bit true also for us programmers. Probably the only thing we know, the only profession we know is programming. For some people, maybe the only hobby we have ever known is programming. So maybe we are like those 2 little fishes. Maybe we aren't really the best people to judge what programming is, because we are swimming in programming all the time, so how are we supposed to know what else is there? So the topic of this talk is my personal exploration of being yanked out of the water, being above the water and being like, wow, there are other things that are programming, and what is my reflection on programming. So let's go back to the year 2008 for this personal reflection. In 2008, I graduated my master's degree from Eindhoven University. For people that don't know the Netherlands, it's a tiny country. And I moved from Eindhoven, which is somewhere there in this tiny country, to Delft, which is somewhere there in this tiny country. For you, probably it's not a big distance, but for someone from a tiny country, a small move is a big move. So I went to Delft, to this nice TU Delft building, Technology University of Delft, and I started to work on a PhD there. The research question of my PhD that my PhD supervisor has set for me was, let's research a DSL for finance, a domain-specific language specifically for finance, a programming language that non-programmers but finance experts could use to program stuff. So we envisioned something like this, a programming language that was easy enough for a banker or someone from insurance to write small little programs that could be executed by a machine, such that the finance expert didn't really need programmers for everything. They could make their own small changes. So this is more or less what we envisioned for a 4-year PhD project. I was really excited. It was like, oh, wow, I'm going to give these finance people a programming tool that they can use. This is going to be awesome. So the first thing I did is I did a little internship at a Dutch insurance company, because before I had only done my master's degree, so I only knew a lot about theory and compilers and stuff like that, but not really about anything in the outside world. This is what they taught me in school. I'm not really sure if they still teach this to people that take computer science courses, but when I was in school in 2008, when I graduated, this was sort of my worldview. There are programmers, and also there are users, and there is a big wall between them, and the users use, and the programmers program. That's sort of, how it is. And sometimes maybe there are tiny holes in that wall where the programmers listen a little bit to what the users want, and the users explain a little bit what they need from the programmers. But in general, you have users and you have programmers. However, when I set foot in this insurance company, soon I saw that this wasn't really the case. That both the programmers, but also the users, were programming. And this blew my mind, because it was already the first chip of my programmer identity crisis, because it's like, wow, users, normal people, the non-programmers, they can also program. But of course, they didn't program like this. They didn't use a programming language, a textual programming language, as we traditional C programming languages. What did they use? Spreadsheets. All the people in the insurance company were programming in spreadsheets. They didn't need my DSL. So I went back to my supervisor. I said, friends, they don't need a DSL in finance. They have a DSL in finance, and it's a pretty good one. It's called Excel. Whatever we are going to come up with in this 4-year PhD project, however amazing it is never going to beat the greatest programming language of history of mankind that has ever existed, spreadsheets. Yeah, you're laughing, but it's true. Excel is such a good programming language that people don't know they're programming. Let that sink in. Think about doing Java accidentally. I don't know. Eclipse just showed up on my machine. You could never do this. And I know it's tongue-in-cheek and it's funny, but it's also true. The step towards using something like Java or C#, it's a step to a different world. Whereas for these people, wow, spreadsheets, you start out with a bunch of numbers, and then a formula, and then a macro, and soon you're accidentally running the entire company. And you could make fun of that, but it's also super powerful. It's so easy, the threshold is so low, and the ceiling is so high. So this became the motto of my PhD project. Spreadsheets are code. It's a real programming language that we should take more serious. However, but it's not just programming. It is functional programming. It's even cooler than just programming. It's functional programming. Think about it. A formula in a spreadsheet cannot have any side effects. The only thing it can do is take information from 2 cells and calculate the result based on that. There's no way that a spreadsheet formula can access another cell's value. So their functional programming is even cooler. And there's some other buzzwords, not just our spreadsheet functional programming, they're also reactive programming. Because if you change a formula in a spreadsheet, it doesn't update everything. It just updates whatever it needs to update. So if this cell updates, it propagates its value to other cell. So they're functional reactive programming. And yet, everyone can do it. Isn't that amazing? So spreadsheets are code. However, they do lack an IDE. And this was the new direction that my PhD project went in. Spreadsheets are a great tool. However, in a sense, they somewhat resemble programming like we did it in the 60s and the 70s. No documentation, not really well structured, not very easy to analyze what is going on. So that became the topic that I really wanted to focus on. Analyzing big spreadsheets and help people understand what is there and help spreadsheet programming move to a new level, just like we had procedural programming moving to OO, moving to functional, helping spreadsheet people structure their stuff. Because often, of course, these spreadsheets aren't just one worksheet. We've seen spreadsheets that had dozens of worksheets, all interconnected, formulas linking them, macros everywhere. So it got harder and harder to really understand what was going on. In a sense, what we were talking about here were code smells in spreadsheets. So code smells, for people that aren't familiar with it, are pieces of source code that they don't necessarily need to have an error, but they're just not structured really well. And maybe a famous example of code smells is a long method. So a very long method. It doesn't necessarily be wrong. It could be perfectly correct. But of course, if you have to debug a 1,000-line method, then it's just going to take more time than a few small methods. And also another famous code smell is code duplication, sometimes also called code clones. If you have similar functionality in different parts of a code base, then it's going to be tricky, because if you make a change, you might have to make the same change to all of the clones, but also maybe you're not really sure what the purpose is of the different clones in the code. So there's just a long list, of course, from code smells as defined by Martin Fowler, but these are some that you get an idea of what a code smell is. And of course, these code smells are really easily transferable to spreadsheets. If you think about the long methods, you might as well think about a very long formula is in the same way not very maintainable as a long method is maintainable. So this is my new direction, and I wrote a number of papers about code smells in spreadsheets like this, and then ultimately I became a PhD. Awesome. So, ta-da, great story. So this is a story, as I've told it many times, like, oh, spreadsheets are code, and then I made some IDE-like features, and I got a dissertation, and yay, hooray for everyone. However, this is sort of the story of my brain, of the rational part of me. And there was also the story of the heart. How was I feeling while I was doing this? A previous edition of this talk, when I gave it, someone said, Felienne is doing group therapy. It's somewhat true, I think, because from here we're going to talk about my feelings a little bit. Because initially, I was super excited. I was like, spreadsheets are code. It's such a great finding, and I'm sure everyone would be very excited to talk about how we programmers could help spreadsheet people to become as awesome as we are. So I went off to all these type of developer conferences to give talks like this, like, spreadsheets are code. And people be like, yeah, but it's not real programming. And I was like, are you kidding me? It is real programming, just like I did before. It's functional, and it's reactive, and it's super cool, and all these people can do it, and it's so accessible, and it's everywhere. And people be like, yeah, it's not real programming. And you can laugh, but it wears you out. After a while, I was just like, yeah, probably you're right. Probably I am spending my time, this valuable youth I have, on a non-problem. And just I got less and less and less excited about it, without really realizing that I was even getting less excited about it. But I was certainly not realizing why I was getting less excited about it. It was somehow, it was dragging me down, and I got less excited and less productive, and I didn't really know why. And afterwards, of course, later in life, I was reflecting on that, on how are we as a community? What are we doing to young people? And at that point, I think, I thought that this was the normal way of the world. I thought, yeah, of course, if you're in a community and you really like something, what you are going to naturally do is bitch on other people's stuff. It's normal. And even though people were doing it to me and I didn't really like it, I was doing it myself. I was in the .NET community. It was like, haha, Java, do you have lambdas yet? So slow. So, and I thought it was normal. I thought it was being part of a community is like, PHP security. So I didn't know that it wasn't normal, because this is how you grow up from when you are, if you start programming, you go to university. This is how people treat each other all the time. Oh, you have a Windows laptop, you fake programmer. I mean, I could spend the rest of this talk dissing all the communities, because I've heard it all, and I said it all. This is just how we treat each other. And only later, after I went to this spreadsheets no longer interesting phase, and also once I started joining other communities, I saw that this is not normal. It is not. I also love running. People that follow me on Twitter might know that I do some running. And after a while, I really also started to do races and stuff. And I'm not a good runner. I'm actually a pretty slow runner. My best half marathon time is 2 hours and 15 minutes. So for the people that don't know running, people that do a full marathon take about 2 hours if they're the best of the world. So I'm twice as slow as the people that are the best at running. So I'm not really good at running. However, you join a race with people that are like twice as quick. And they're like, oh, but we love running. And how often do you go? And what shoes do you have? And no one in the running community says, what's your time? Oh, that's so slow. oh, really? You have Adidas shoes? No, those are... Everyone's like, oh, that's great. And even worse, non-running people that have running friends know this. We are actively trying to make this community bigger. If you have just gone on a jog to catch your train, we runners be like, oh, you like running? Do you want to go for a run? It's great. We can join the race. What is your 10K time? We want people to like running because it's awesome. Running is great. It's way nicer than sitting behind a computer. And only then I started to realize, hey, wow, there are these communities where people are not shit to each other. That is super nice. And I also, people that follow me on Twitter or see me around at conferences know that I love knitting. Knitting is so great. It keeps your hands busy. You create stuff. It's like a fidget spinner for adults. And also, I do it in meetings too, especially conference calls, because you have to keep paying attention. Initially, I was just doing my email and then muting my microphone, and then after 10 minutes, Felienne, do you have anything to add? Like, what, wait, who? Oh, I was in a call. So knitting is great also for conference calls. And then the nicest thing is, suppose you're in a useless call for 1 hour, at least you finished half a sweater. So it's not lost time. But also the knitting community was so nice. I had knitted a lot as a teenager, but I sort of stopped doing it when I was in university. So after 10 years of not knitting, I went to a workshop. And apparently, you won't believe this, but the knitting community also has fashion. They're like, oh, these needles are a bit old-fashioned, and now we use these new techniques and these new needles. So I went to this knitting workshop with my old-fashioned straight needles. It's very much out of style. We all use round needles now. I didn't know this. So I come to this workshop, and no one is like, oh, your old-fashioned needles, they're shit. They have security breaches and everything. You need a patch for them. Everyone's like, oh, it's so great. You come back to knitting and welcome. We see you have these needles, but look, we have these other needles, and they're better in this way, and they're better. This is just nicer for your hands and stuff. But no one was dissing my old-fashioned knitting. I was like, wow, we should all do more running and knitting and everything that's not programming. We can have nice communities, and of course also in the running community, and also in the knitting community, and I'm sure in other friendly, inclusive communities as well. People do discuss tools, of course. They say, I like this needle more than that needle, but they would never really bicker on people that use something else because they want people to feel welcome. Wow. Okay, let's go back to 2012 when I was not happy and I had no clue about communities that could potentially be nicer. So I'm at this point, I just finished my PhD. I started a professor position at TU Delft, where I was supposed to do more of the cool spreadsheet stuff, and I was totally uninspired, and I didn't really know what to do. I didn't really want to do more spreadsheets. I didn't really know why. And then I'm just feeling sad. And then this happened. I moved cities. I started to live in Rotterdam, and there was this community center with a bunch of kids that said, hey, we would love to learn us some programming. I was like, okay, I guess I could do that. I can do programming, so probably I can teach programming to children. Like that's the same thing. So I was like, okay, sure, kids. I will teach you some programming. Let's do it. So I went to work every Saturday at that community center and taught some kids that were interested in programming some programming. And they had a Lego robot, a Lego Mindstorm set. Who has a Lego Mindstorm set at home? For your kids, right? It's really cool. So it's a Lego robotics set. It has motors and sensors, and you can build all sorts of robots with it. And also you can program it with a programming language that's a data flow programming language. It looks more or less like this, where you have blocks. You can connect them with wires, and that's how you program the robot. So you could say something like, wait until you see an object block, and then connect it to a stop the motors block, and then the logic would run like this. So one Saturday, kids have gone home, and I'm looking at these programs, and they look a little bit like this. I'm like, it's not very well structured, is it? I think I've seen this before. Non-programmers making programs for a specific goal, but it sort of lacks structure. It lacks an IDE. These are code smells in Lego Mindstorms programs. These kids are doing the same thing that the accountants were doing, very much being goal-driven. They didn't care about making a nice spreadsheet. They cared about their budget. Much like these children didn't care about the nice program, they cared about catching a soccer ball or whatever we were programming. But they didn't really analyze the structure. They were really bad at managing the code because they were very goal-oriented. Code smells in Lego Mindstorms. It's like, hey, that's nice. I know it's Saturday. And I know I shouldn't technically be researching on my day off. However, I haven't done lots of spreadsheet work in a while, and I'm sure that my head of department would be happy if I would produce any research. So let's just write one little paper about code smells in block-based programming languages. Then at least I have something to show for at my annual review meeting. Even though it's not really what I was supposed to do, let's just write one little paper. Of course, you know, there's 35 more minutes left in this talk that it wasn't just this one paper. This was interesting, because then I was wondering, does it actually matter to children? Are code smells really bad? Because these are small programs, way smaller than the accountants' spreadsheets. So maybe it doesn't really matter to children that there's some smells. Maybe they're just programming very exploratory, and it's okay if there are some smells because the main focus is on learning. So at this point, I moved to a programming language called Scratch. Who has played with Scratch? For your kids, right? Absolutely. So this is Scratch. This is the interface that you start with. So you can see it's also a block-based programming language, but it's a little bit different from the Lego Mindstorms, where you connect the blocks with wires. Here you connect them as puzzle blocks. And it's a live programming environment, so if you change something here in the code blocks, immediately the program will update. You don't have to compile or run. It just runs while you're editing it. And as you can see, it's very, very colorful, very encouraging for children to play with, to make games, to make animations and stories and music. And it's made by MIT. It's free and open source, so everyone can play with it, and you can also localize it. So of course, most people speak English, but many kids, Dutch kids, speak a little bit of English, but not perfect. You can set the programming blocks to be in Dutch or Danish or whatever language you speak, and that makes it a lot easier for children to program. So if you haven't checked it out yet for your kids, it's really very nice. So we did a second experiment, and now I got some fresh kids, not the kids in my Saturday club yet, because after a while it gets sort of unethical to experiment on children. You're also supposed to supervise on Saturday. So we went to a local high school with some fresh kids, and we divided these kids into 3 groups. So one group got nice Scratch code, nicely structured, well-organized Scratch code. The second group got code with lots of duplication. So we repeated these puzzle block stacks in small varieties, very much like you would see code duplication also in professional code bases. And the third group got the same Scratch code with no duplication, but with very long stacks of blocks. Very much like a long method, we just stack up lots of blocks together and made it as messy as possible. And then we asked kids to look at a game that we programmed, a breakout game. So you have a bat and a ball, and you have to remove some blocks. And we asked the kids to explain the source code to us. So it was fresh source code they had never seen. They could play with the game a little bit, and we asked them, what is this code doing? Explain it to us. Both the whole program, but also small instances, parts of the program. What is this specific piece doing? And we also asked them to adapt the source code a little bit. So for example, the game would run until 5 points, and then you get a sound, and they had to change it until 10 points, and only then the sound would run. And what we found, answering the question, are code smells bad? Quick answer is yes. We found that the kids with a nice source code did a lot better on explaining and adapting tasks. So even in these small programs for novice programmers, they had an hour of introductory Scratch before, and then we presented them with the exercises of the breakout game. It does matter to kids if there are code smells in their program. So if we all produce messy code, if children produce messy code, then it does impact the understanding of that source code if they read it or their neighbor or whoever is going to read it. So yes, it does matter. So we're like, okay, maybe 2 papers, maybe explore this a little bit more. So then I wanted to know, are these code smells common? Do they really occur in practice? Because in this breakout game, of course, we had inserted the code smells, but maybe, just maybe, real children would not make code smells. Maybe they were all producing fantastic code. Could be, you never know. And this is research. At this point, I was like, oh, this is going somewhere. So Scratch isn't only free and open source itself, but it also has a Scratch repository. It's a little bit like GitHub, where kids can share their programs, and they can also fork the programs of other kids and adapt them. In Scratch, this is called remixing, but it's essentially the same thing as forking. And this repository is also available to analyze. So if kids share a program, they agree that everyone can do whatever they want with programs. So if you see a Scratch program, you could play it. You could also print out the source code or download 250,000 Scratch programs and do some static source code analysis on it, if that's your thing. Well, that's my thing. So that's what we did. We analyzed these programs, and we looked at what are those programs? How are they structured? And we found that 30% of the programs in the public repository suffer from the long meta smell, which is quite similar to professional source code smells levels. We also found that 26% of the programs suffered from duplication, so code clones, a number of different varieties of source code spread over the program. So it seemed like these kids indeed were producing smelly programs, much like professionals, and this could hamper future understanding of these programs by other kids, as was demonstrated by the previous experiments. We also found one more thing that was very surprising, and at that point I couldn't really place it anywhere in my understanding of things, but we found that only half of the programs had user interaction. So only half of the programs did something if you clicked a mouse, pushed a button, made a sound, and the other ones were static programs in a sense. Stuff was happening, but you would start them, and then they would just do stuff. I was surprised by this. I was like, that's weird. It wasn't what I was looking for. It sort of stuck somewhere inside of my skull as a fact that I knew, but I didn't really know what to do with it. And of course, this paper was about exploring the code smell, so I sort of remembered it, but otherwise I didn't really touch it. At this point, you're getting this, I guess. I'm like, oh, this is going somewhere. All these papers build up upon each other. Now what I wanted to know was, can we make the world a better place? Can we explain children about code smells and tell them that it's just not a very good manner to organize your code in a big stack of blocks? If it's possible, you should split it up, because then we would prepare the future for better programmers. And of course, this is a slightly selfish motif here, because these 8-year-olds programming Scratch, in 10 years, they'll be in my university classroom. And then if I say, hello, kids, good morning, welcome to the university, don't do code smells. They're all like, why? We've been doing this forever. You tell me now. So it's like, maybe if I can tell them a little bit younger that code smells are a bad idea, then after a while, in a very long time, then maybe I'll get better, more mature students. Dream of every university professor, of course. So that's what we set to find out. We wanted to know, is it possible to explain to children that code smells are bad? So what we did is we've created a free course on edx.org, a website that's normally used for massive open online courses for adults, but they were open to the idea of offering a course for young children there. And in the first run of this course, 3,000 kids participated in learning Scratch online through YouTube videos and exercises. And we told them that it was a programming course, but secretly we explained programming to them, but also code smells. And we explained it like, this is the way programmers like. They like to organize everything. They like a clean working space. If you don't need your code anymore, you will remove it. You will make comments. We're moderately lying to them about what programmers actually do in life, but it was for a good cause, so just bear with me there. We told them this is what programmers do. And we closed the course with questions about programming, but also questions about code smells. So for example, we would present them with a program saying, hey, here's a program where one block is redundant. You could remove it. What block should you remove? Questions like this, where we could test, do people really understand, or do the children really understand what a code smell is and how to fix it? Well, short story, yes, we can teach children about code smells. We found that on average, they scored 72 out of 100 points for the programming part and 85 points out of 100 for the code smells question part. So from this, we could conclude that indeed it was possible to train children as young as 7, kids in the course were between 7 and 11 mainly, we could teach them about code smells. They understood it. They knew how to do it. Of course, the open question here is if they would actually do it if they were free playing. But at least with this experiment, we had demonstrated that it is possible to explain to children what is and what isn't a good way of organizing source code. So at this point, a year in, I think, since I started working on this, I'm pretty convinced that this is my new topic. I'm like, spreadsheets, no. Programming for children, yes, that is where I'm going. So I thought it might be a good idea to look back on what I had done. How research normally goes, at least how researchers pretend research normally goes, is you have a big plan, and you divide that big plan into little chunks, and then you execute the chunks one by one, and then you have a big story. But that didn't really happen here because I sort of fell into it and then started running. So I never really made a big plan of where am I going, what are the research questions I'm answering. I just started it to do something. So I thought after these 4 papers, now it's time to look back at what I did and make a bigger plan to work on this longer. And this is when this water of programming thing really started to dawn on me. Because looking back on all these papers I had just written, I realized that I was making so many assumptions. I didn't realize I was doing it when I was doing it, but when I was looking back, I was like, wow, you have a small, a narrow view on what programming is. Look at all the assumptions I made. One of the assumptions I made is the domain is really irrelevant. For this first experiment where we wanted to see if code smells are bad or non-bad, I just picked a game. When I was talking with a co-researcher that also worked on this paper, looking back at that decision, like, did we even consider to do something else? Did we even think about doing not a game? No. We just thought, oh, programming, games, kids still like it. Oh, just assuming that game programming is equally interesting or exciting to all the children in the experiment. Later, this is a recent paper that just appeared in November of 2017. Other researchers in Germany, they taught children free programming for 3 days, and then they analyzed the programs that the kids made. And only 3% of girls made a game. So maybe in just ignoring the domain, we had made some kids more excited about programming than other games. The other assumption, and this was this nugget of information that was still stuck in my brain, but I didn't really know how to process. I was assuming that software does something. I was so surprised when I found that only half of the programs had user interaction, apparently because I was assuming that a program without any user interaction is a weird program, or maybe even a non-program, or a fake program. However, this is apparently what the children were interested in. Rather than making games that would, of course, respond to user inputs, they were very interested in making animations, stories. You just click a button, and then a princess walks up to a cake and says, I'll eat this cake. And the cake says, no, don't eat me. And then the princess says, OK, let's be friends. And then they go. These are things that some kids were really excited about, making an animation where there was no user interaction at all. So our perspective as professional programmers making software for a customer that most likely wants something to happen if they click a button is already only a small part of what programming could be. Commercial programming isn't necessarily programming. And the third assumption I made is that building is learning. When I started the course, the online course, when we designed that, I just thought, OK, I'm going to explain to children what programming is by programming. But it isn't necessarily, of course, the only way that you could teach programming. You could also say, let's first read some programs together. Or let's first brainstorm on what it is we actually want to build, rather than diving in immediately. So there were so many assumptions I was making. This is just a few of them. It's like, I really want to be better at this. I want to have a broader view of programming, because if I'm really going to teach children for a very long time, I need to be as open as possible on what programming is, because otherwise I might accidentally drown them in my water of programming rather than having them show me what they can do with programming. So one of the things I started to do is I asked children in my Saturday club again, what do you want to build? Rather than coming in with ideas myself or with sheets of lessons we downloaded from the internet, I asked the kids, what do you love? What do you want to build? And they come up with the weirdest thing. There was this one kid in my class, I will never forget this. He says, you know what I really want to do, Teach? I want to build a website for the local supermarket. And you just have to like bite your fist and go, friend, the thing has a website. It's a big international chain. They really don't. So I'm like, okay, that's cool. Why? So that people in my neighborhood can see when the supermarket is open. And I can make pictures with my phone of everything that's for sale. And it's really nice because then people don't have to go to the supermarket to decide if something is there. They can just see from their home. I'm like, okay, we'll build that. And he was so engaged. He was way more engaged than in building games because this is what he was excited about. He wanted to use his programming power to make the world better, probably for his granny or mom or dad, I don't know, someone that apparently was struggling with knowing when the supermarket was open. It was just shut up and listen to what I want to do. It was amazing. Something else that we actually did is Donald Duck. So I don't know how this is in the UK, but in the Netherlands, we have a weekly Donald Duck magazine. It's a very popular magazine. There are 17 million people in the Netherlands, and there are 1 million Donald Duck magazine subscribers. It is the most, I'm not kidding, it's the most read magazine among 18 to 25-year-olds. It's very, 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 very popular. I have a subscription myself. I'm not ashamed to tell you that. So this Donald Duck universe is something that's very well known in the Netherlands. And the nice thing is it's a very rich universe because in the same universe you have different types of stories. You have Scrooge McDuck wants more money and goes on a treasure hunt to find more money. Let's teach children about capitalism stories. You also have Daisy Duck and Donald Duck and they go on a dinner date and then Glander comes in and ruins everything. Let's teach children unhealthy ideas about romance type of stories. Mickey Mouse mystery stories. There's a plethora of stories to pick from. So one of the things we did in the class, this is the class, is I brought these Donald Duck magazines that I have plenty of at home, and I let them pick a story to reprogram in Scratch. So the nice thing is they were all in the same universe, so they could exchange ideas and talk about each other's plans, but they could also be very personal in what they wanted to do. Some kids copied the stories to perfection. They really want to have all the pixels exactly as in the magazine. Some kids just took the story as a sort of inspiration and then went on their own adventures. So it was really nice because it allowed them freedom, but also a shared experience. We also tried this with Pokemon because it was super hip at one point, but not all the kids had enough knowledge about the Pokemon universe to really respond to each other's ideas. So that was really nice about this Donald Duck. I also went to explore the idea of no interaction. What does programming become if we remove interaction? So I challenged the children to think about what could you make if it's no interaction? So one of the things that they came up with was artworks. So especially Mondriaan. Mondriaan is a Dutch painter. You probably know him with his pictures with lines and boxes. We could create such a program relatively easy with Scratch. So here you have a big classroom. This is at the university where I gave a guest lecture to young children, 10, 11 years old. I had all of them draw a Mondriaan. So we could look at the variety of Mondriaans that they could come up with. And then we together programmed a program that could generate as many of those Mondriaans as possible. For example, one had blue and the other one had yellow. Okay, that means that color is a parameter. Some people had lines like this or like this, but other people had diagonals as well. Okay, that means that the direction of the lines has to be a parameter. So by doing this, we could reflect on programming, but also on what exactly constitutes an artwork. What was interesting / sad about this experiment was these are 10, 11-year-olds. And they knew that they would get a programming lecture. But then I gave them a sheet of paper and some pens, and I said, draw a Mondriaan. Some of them were upset. They were like, this is supposed to be programming class. Why are you making us draw stuff? This is stupid. They were already drenching in what apparently other people had told them that programming was. And we also asked them, what do you think programming is for? Apps, websites, robots? There's nothing necessarily wrong with that, but already their view was pretty small, and they didn't really immediately understand that programming and artworks were something that actually matched. It took a while to see that. And then this final assumption, the assumption that building is learning, that if we want to teach children programming, the practice we're going to give them is building programs. It makes so much sense in the context of programming, but it makes so little sense in other contexts. So, for example, go back to running, which I love. Maybe you didn't know this about me, but I love running. So if you're practicing running, you're never going to practice the real distance. So suppose you're training for a 10K. You're not doing a 10K every day. That is not good practice. What you're doing is maybe a longer distance, 15K, on a slower pace. What you're doing is 5K as quickly as you can, or with some interval training. You might also do weight training. You might change your diet a little bit. There's all these other things that you're doing. You're not training for a 10K by doing a 10K. However, if we're programming, we're practicing programming by doing programming. Why don't we have all these small little exercises that you could do that would also definitely make sense? No one thinks doing some cardio fitness isn't going to help your running, even though they're arguably really different. So this was a tough assumption. What is the reverse of building is learning? And I was thinking for a long while, what actually is programming? What is it, and how could we train it, and how could we teach it? And at this point, I was doing a sabbatical in Cambridge, so I was in a different environment, hanging out with different people, thinking about it a lot. So it wasn't really that I was just thinking myself, and this brilliant idea hit me. It was lots of conversations with really smart people that I hung out with. It's like, I get it. Programming is like writing. And it's sort of weird, but it also totally makes sense to me, at least. Because if you're programming, you have this high-level idea. Like, for example, an app that tracks compliments. I would really like to have that. If people say nice things about me, I'm like, say that again so I can record it with my phone. You go from this high-level idea to letters and sentences. Maybe in the middle you do some planning. You think, okay, these are the classes, or these are the screens of this app, or whatever. You do some planning, but ultimately you go from a very high-level idea to letters and numbers. Suppose you have a high-level idea for a novel, something like A Frog Murders Foreign Diplomats. What do you do if you want to write a novel about an idea? You take this very high-level idea, and you translate this idea into words and sentences. And maybe you have some planning in the middle. Some novelists use character sheets or organizational sheets of who knows each other and who meets each other. But ultimately, you go from a very high-level idea to words using some technique. So this idea struck me as being very interesting. Hey, I see the similarities between programming and writing, and what could we do with it? But of course, these spreadsheet-hating people hadn't really disappeared from my memory yet. So I was like, oh, people are going to tell me that this is bullshit and it's not real, whatever they like. So I was like, why is this interesting? What does it matter that programming is like writing? I mean, if you generalize often enough, everything is like everything. Like, this is a thing. I'm a thing. I'm the clicker. Do I click? Like, you can think about these things for a very long time and lose any relationship with reality. But this programming and writing thing, it did give me some things. One thing that it gave me is that writing has some really nice ideas that helps us reflect on programming. In writing, you have this idea of two different types of writers: plotters and pantsers. And plotters have an idea, and they really think about it for a very long time, and then they write something. So the first step they do is thinking, planning, making a perfect plan in their brain, and then write something. I know these people exist because my PhD supervisor is definitely a plotter. He could just sit like this and then write a perfect paragraph. It's terrible. But in writing, you also have this other category of people, pantsers. I'm a pantser. So what pensers do is if they need to do something, if they need to write something, they just sit, this is where the word comes from, they sit on their pens and they start writing. So the first step is just write. Write. And then they rewrite and they adapt and maybe they give it to someone, they ask for feedback. So these are two strategies that are very different. And famous writers put themselves into categories. They say, oh, I'm really a plotter, I'm really a pantser. And this, for me, only knowing this for writing already made me feel better. I'm like, okay, this is a thing, and other people are pantsers, and it's not ridiculous that I have no plan, I'm just typing like a maniac. This is a type of person you can be, and it's also a valid way of working. So for writing, it also made me better. But of course, you also have this in programming. In programming, sometimes you are pantsing programming. You don't really know where you're going, you're exploring a certain space, you're just writing, changing, and sometimes you are plotting programming. Sometimes you have requirements that are really clear, you have everything in your brain, and you write it. And also probably in programming, there are people that are more towards pantsing and people that are more towards plotting. So this idea from writing helps me understand not just my writing style, but also my programming style and other people's programming styles. So this is a discussion you could probably have in your team. Maybe you're having this in your brain right now. You're like, am I a plotter, am I a pantser? My colleague Harry, oh yeah, he's definitely a pantser. Now I understand why he's always committing things that aren't clear, because his brain just doesn't work like that. He needs to get it out first. And these metaphors that we use for programming, they really shape the way we see programming. So I know there are many metaphors. People say programming is like cooking, programming is like gardening, programming is like writing, programming is like engineering. But that final one, programming is like engineering, is quite widespread in our industry. We often say things like, I'm a software engineer. Courses are called software engineering. We say architecture, we say scaffolding. So this metaphor of building and engineering is very much spread throughout our field. And there's of course nothing bad about that, but one metaphor might be very suitable for one type of person, and another metaphor might be really suitable for someone else. For example, if you're making a bridge, if you're in this engineering metaphor, that's a very welcoming situation for plotter-like persons. I'm making a bridge. Okay, I have this bridge in mind. I'm designing this bridge, step, 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 and now I'm building this bridge. So the engineering metaphor and plotter people go hand in hand. That makes sense. But if you're a pantser, like me, engineering doesn't really fit. You can't pants your way out of a bridge. Okay, work with me here for a little while. Okay, we just put the steel over the water. Oh, it falls. Oh, yes, yeah, you're right. No, I should totally have seen that coming. Okay, let's try again. It doesn't work. So the fact that this engineering metaphor is so well spread throughout the community probably makes some people feel very much at home and other people not so at home. Because people that aren't able to really immediately see all the implications of architecture might not really fit in a programming world in which everyone thinks that engineering is what we should be aiming for. So in this sense, the metaphors we use really shape our fields. It's not this fun thing where you say, oh, programming is like engineering, but it's also like cooking. Dominant metaphors really matter to how we see our field, how we see ourselves, how we see the ideal view of someone that is a programmer or a software engineer. And I found that this language metaphor really helps some people to feel at home and really helps to place some things in perspective. For example, with language comes the assumption that everyone can learn it. Everyone knows a language. You have your own language. Maybe you know a second language. Even if you're deaf, you might know sign language. If you're blind, you might know Braille in addition to spoken language. Everyone knows a language, and this especially matters for teaching children. Because in teaching children, we have this other metaphor, not the engineering metaphor, but the mathematics metaphor. If we keep saying programming is like math, it's like logic reasoning, with that metaphor comes the idea that it's tough, that you have to be born for it. Otherwise, you can't do it. Whereas a language, everyone can learn it. So if we keep saying programming is mad, maybe some people think it's not for me. And this is not a hypothetical thing. There's lots of research that shows that the more people believe that a certain skill is innate rather than trained, the less women participate in the field. So this is not like, oh, this crybaby thinks it's hard and they're dropping out. It's important because if people think, it's not for me because I don't have the right genes, they'll drop out. So this is why I really, really, really like this language metaphor, because to a way lesser extent than with mathematics, you know that language takes practice. If you want to learn French, even if you're good at learning a language, you will still need practice. And you will also need practice forever. I had 6 years of French in high school. If you drop me in France now, I'll never get back. You need to keep practicing this skill. And these are all things that come with this language metaphor. It's not innate, it needs practice. Everyone can do it. So it's a really nice metaphor, especially when you're teaching kids. Another thing that I really like about this language metaphor is some stuff makes no sense at all. In mathematics, stuff makes sense. In language, some stuff makes no sense. Who is Dutch in the audience? Some people. Okay. Oh, Bella, so you speak Dutch?
Yes.
Okay, that's good. So you'll extra enjoy this example. So here's me. This is me as a teenager learning English. So I like languages. I like Dutch. That's a good language. So here I am. I read a book. So my teacher's like, well done, Felienne, you are getting the hang of this. Now the next sentence comes. Okay, I've read a book. I've read a book. No, it's I've read a book. Why? Why, English people? Why are you doing this to us? I'm not sure if you even know this, but there are languages, like Dutch, for example, that have a one-to-one mapping from letters to sounds. This might come as a shock to you, but this is a thing that languages can actually have, where an O and an E combined are always the same thing, and an E and an A combined, they're the same thing. It doesn't matter in what word or sentence you place them, they're the same thing. So in a similar sense, of course, some stuff in programming just does not make sense. Why does the one language have a semicolon at the end and the other one doesn't? There is no logic. So if you tell people this is like math, there's pure logic. Logic reasoning is the skill you need for programming. And then you present them with absolute non-logic, maybe they will think, this is not for me. This doesn't make sense. So this language metaphor also helps us to see that languages, also programming languages, are made by people and they're not perfect. And sometimes they're absolutely illogical and it just doesn't make sense what they're doing. So that's another benefit, I think, comes from the metaphor of programming as a language that's especially useful if you're teaching people. Some stuff makes no sense. You just have to accept it. So these are things for which I say, yes, let's broaden our horizon into not just saying programming is math and logical reason, but also saying programming is like a language that is made up by people that sometimes make weird decisions. Oh yeah. Make me extra love Dutch. Such a good language. So to close this off, when I have gone through this period of programming is like writing, I was like, okay, so now what can we do with that? Because it's a nice metaphor and it might make our community better, but what can we concretely do in teaching children? And it might surprise you to know that there's a lot of research about how people learn a language. I dove into all these papers about how do you teach language, and we know so much about how people acquire their first language. So much more than we know about how people learn programming. So one of the debates in learning a language is the phonics versus the whole language approach. These are two different approaches of how you should teach reading to children. And there are sort of competing schools, and some go in and out of fashion. But the basic idea is Phonics is where you really focus on the letters and the sounds. You first practice all the letters and the sounds, and only then you go to words. So, for example, you would read this really as r, e, d, read. This is how you practice. You practice all the letters one by one, and then you get the reading skill. The whole language approach is putting things into context. The philosophy behind the whole language approach is children like language. They're already in a language-rich world. They can already speak. So rather than focusing on the mechanics of reading, we're just going to give them sentences, give them stories, let them write, even though they can't write yet, so that they practice their muscle skills, and after a while, you get reading. So there are competing schools, and as you can already see from this example, maybe you understand why the phonics approach is very popular in the Netherlands, because we have this one-to-one mapping, and it totally makes sense. Whereas in England, whole language approach was popular for a very long time. It's now shifting a little bit, because you can't really do the read, because it depends on the place in the sentence, if it's read or read. But still, these are competing schools. And then if you focus on programming, what do we do as programming? We very much focus on the whole language approach. We teach children programming, whole programs immediately. We say, okay, this is an if, and now you place it in a context. Now we're going to make a higher-lower game or something like that. But how would a phonics approach look like in programming? How would programming class go if instead of saying, we're going to make this game, and for that you need these building blocks, we would say, here's an if. And before we move any further with anything, we're just going to make sure that you know what this thing is in any context. We will give you this building block, practice, 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 and only then you get to apply it. I don't know, but it would be interesting to explore how that would look like. And potentially, again, we're talking about context and metaphors. If we practice all the concepts separately, we remove some of the context. We don't have to choose for the first lesson, do we do a game or a song or an artwork? We can just focus on the building blocks and see how kids put them together. So this is something I'm really excited about, exploring. Can we teach small building blocks without giving too much context? And this is more the whole language approach, and this is one of the things, this is in Dutch, sorry, one of the things we're trying to teach children separate programming blocks and have them practice what a specific block means. This is setting a variable before they get to apply it somewhere. And you see that this isn't even context-free if you know Dutch, because punten means points. So it's already, again, directing a little bit at games. We're trying to keep it as free from context as possible, hopefully leading to the fact that children can then come up with weird ideas like the supermarket stuff that I could never come up with. Another thing that's really, really, really nice from language education is we know the stages children go to when they're learning a language. We know the things that they believe to be true while they're actually false. So children, this is an experiment done on 3-, 4-, 5-year-olds. They can't read yet, but of course they see language all around them. Ads, newspaper, milk cartons, everywhere is language. So we know that they have hypotheses. For example, children that can't read yet, if you present them with a word with all the same letter, they'll say that's not a word. They don't know, they don't read yet. They have no clue of how to pronounce that, what it could mean. They say, no, same letter, not a word. They also say that non-words are words. So they would decide that bza is a word, because it has not all the same letters. There are different letters, so it must be a word. It looks like a proper word. Maybe there is a human language in which bza is a word. So they have a hypothesis that that's a word. Okay. Another hypothesis that they have, if they're reading, they're learning to read a little bit further, they think, okay, in a word I hear sounds like mama. So maybe a letter could present a sound. That's the next hypothesis they have. A letter could represent a sound, mama. Okay, that makes sense. So now they have sort of a conflict of hypotheses, because they say, could be mama, but they also say, no, it doesn't really look like a word because it has too few letters. So the fact that these two hypotheses bump into each other makes them form a conclusion. Okay, so I was thinking that a letter is a sound, a syllable, but I'm also thinking that a short word can be a word. So then probably I have to come to the conclusion that letters make sounds, that letters represent sounds rather than syllables. So we know very, very well all these steps that children go to. First they believe this, and then they get another nugget of information, and then they believe that, and then they believe that, and after a while they know everything that they need to know about reading. So we are studying these type of hypotheses now also in the context of programming. And in programming, they're commonly called misconceptions. So we're studying ways in which children could be confused about programming. And here's a common way in which people could be confused about programming. We, of course, aren't, but take 1 second to think about what this would print. So some novice programmers believe that this would print 5 and also 7. Because a common misconception about variables that children have if they learn through programming, also, by the way, adults have this misconception if they're learning programming, is that a variable can hold multiple values. That somehow this first value is remembered. So we're thinking, what are things we could present to learning programmers to make them quickly break this hypothesis? What is a program that we could show that they say, oh, wait, it doesn't work like that? And just this printing probably isn't a very good strategy, because what we know about misconceptions in other fields is that if people have a misconception and there's lots of scary stuff, they tend to hold on to the misconception because at least that's something they think that is correct. So we're exploring different ways of explaining programming. Here's another common misconception that novice programmers have. So take a second to decide what that would print. So some novice programmers think that this will only print 0 because they think that the loop stops as soon as B becomes false. And this is probably a misconception that comes from natural language, where if you say, while I'm away, you should do something, then that if you come back into the room, immediately people would stop doing it. It isn't like first we finish this talk and then you get to do it. So probably this comes from the word while, meaning something slightly different in normal language than in programming language. This is another nice idea of, it doesn't really make sense. So together with my PhD student, Alan in Sweden, we are studying these type of misconceptions and also what we can do to quickly alleviate them so that people learn programming. And this is all based on this idea that from language we have so much knowledge about the type of wrong things that people believe and how they need to follow in order in a logical fashion. Because for language we know that kids need to go through these stages. If you have a 3-year-old, you can tell them letters are sounds, but it doesn't stick yet. They don't have enough knowledge. They need these phases to learn. So that's one of the newest things I'm working on that I'm very excited about. So that's it. That was my talk. I hope you have a great NDC. Before I send you off to coffee, I just want to wrap up my talk in 1 minute. So if you came in late or if you're like, oh, it's so early, it's your second chance to get the most important things from my talk. First thing is listen to your heart. It took me way longer than necessary to realize I wasn't excited about spreadsheets anymore. I don't know how you should do this, but checking with yourself, am I still liking what I'm doing, I found to be very, very, very important. So if you're not liking something, figure out why and don't just continue for a year too long. Second thing, realize that we are all in the water of programming. Look around, look in this room, see how incredibly similar we all are in various ways. It cannot be that we represent programming. The fact that we're all so similar, we're doing similar things, like making software that we sell for money, is only a small part of what programming is. So try to do whatever you think in your community or life to figure out what else programming could be for you or for other people. And don't be those people. I'll be here all NDC. If I catch you not real programming to anyone, I'll find you. I'll find out where you live, and I'll come to haunt you. So don't be that people. Be the knitters. Be the runners. Be like, programming is awesome, and everyone is welcome. Third thing that's important, the metaphors we use shape the way we think about our field. If we continue to say software engineering, I mean, it's fine. I'm not saying don't use it, but realize that engineering might be a welcoming metaphor to some people and not to other people. So a diverse group of metaphors is probably also going to result in a diverse group of programmers. And programming is writing. This metaphor, for me, has made my life richer and more interesting because there's so much to reading and writing, culture, accents, languages, countries. This, for me, is a very, very rich metaphor that I hope to work on for a very long time, and I hope no one comes to not real programming me out of this love, because probably my generation will have pension at 100 years. So I hope it stays fun for a very long time. That's it. I'm at Felienne on Twitter and Instagram. I also have a blog, felienne.com, where I also review programming sets for children. So if you're trying to figure out what's fun to buy for your children, you might want to check out my website. I'm not doing Q&A because we don't really have time, but there's one question that I always get, and I just want to answer it. People ask me, how do you make these slides? So I have an Apple Pencil, which is a nice piece of technology, and an app that's called GoodNotes. So just a shout out to Apple and GoodNotes because they allow me to do these awesome slides. And a special thank you to some people that are really important to me, have been important to me in this last phase of my life. Thank you, and enjoy NDC.